In this video, we're going to be solving for the axis of symmetry and also for the vertex of a quadratic. So let's go ahead and start. What is an actual axis of symmetry? The axis of symmetry is going to be a vertical line, so vertical meaning up and down, with the equation x equals, that splits a graph making each side mirror images of each other. So if we take a look at this quadratic here, it's going to be, the axis of symmetry is a vertical line that has the equation x equals, and it's going to be x equals 1 to -3, and it splits the graph in half. And so what we mean is, like, when we look at, say, the roots, right, this root is 3 units away on one direction, and so the root on the other side is 3 units away in the other direction. Moving up, we'll take, say, these points here. This point is 1, 2, 3, 4 units away in one direction, so guess what? This point is 4 units away in the other direction. Okay, so it's always halfway in between. So where is the axis of symmetry? It will always be halfway between the roots, or really halfway between any points with the same y coordinate. And this becomes helpful because the way that we actually solve for the axis of symmetry is, since this axis of symmetry is halfway in between this root and this root, the way that we solve for half of something, right, is we add those two things together and divide by 2. So to find the middle, you'll add root 1 plus root 2, and then you're going to divide by 2. So root 1 is here, and that's a coordinate of 1, 2, 3, 4, 5, -6, 0. This one has a coordinate of 0, 0. So -6 plus 0 divided by 2. And -6 plus 0 is -6. And -6 divided by 2 is -3. Which is what we already said our axis of symmetry is at, just by looking at it. So again, to find the middle of something, you add those two things together and you divide by 2. It would be like if you have 10 flowers and I have 6 flowers. If we wanted each of us to have half of them, we would add them together and divide by 2. 10 plus 6 is 16, and 16 divided by 2 is 8. So each of us would get 8. It's the same thing. Let's find the axis of symmetry for this one here. Again, it's the single line that splits the graph in half, and as you see, it's at x equals 1. So this root is at 1, 2, 3, 0, and this root is at -1, 0. Right? I'll write that in pen. So if I wanted to solve for the equation of the axis of symmetry, I would add the roots and divide by 2 to find the middle. Root 1 is 3, root 2 is -1, and divide by 2. 3 minus 1 is 2, and 2 divided by 2 is 1, which is what we got. Okay? We'll do more examples. So next we're going to talk about the vertex. Another word for a vertex is a maximum or a minimum. But the vertex is going to be the turnaround point of a quadratic. It's at its highest or lowest point. So the vertex of this graph would be this coordinate here, because that's where the graph goes and turns around. The vertex of this graph is going to be down here. That's where the graph goes and then turns around. Where is the vertex? The vertex is at a coordinate x, y, and if you notice, it's always going to be on the axis of symmetry. what that tells us is the x-coordinate of this point will be the axis of symmetry. The coordinate of this point, 1, 1, 2, 3, 4, 5, 6, 7, 8. The coordinate of this point is 1, 2, negative 3, 1, 2, negative 3. So as you notice, because the vertex is on the axis of symmetry, whatever the axis of symmetry is, that will be the x-coordinate of the vertex. Lots of information. We're going to go ahead and do 2 examples. So, to quickly recap, we know how to solve for y-intercepts. Y-intercepts happen when x equals 0. So y-intercepts always have the coordinate 0, comma something. I went ahead and did all that math before this video. So the y-intercept is at 0, 5. X-intercepts happen when y equals 0. So they're always something, comma 0. I went ahead and did that work before. And as you see, I get 5 and 1. So I'm going to go ahead and graph all these points. 0, 5 first, so 0, 1, 2, 3, 4, 5. That is my y-intercept. 5, 0, 1, 2, 3, 4, 5, 0. 1, 0, 1. Excellent. So these are my roots, and this is my y-intercept. So I'm going to go ahead, I'm going to solve for my axis of symmetry. My axis of symmetry, I will take my roots and divide by 2 so I can find the middle. Technically, I could probably do that by just looking at it, but we're going to solve. Root 1 is 5. Root 2 is 1. Oops. 5 plus 1 is 6, and 6 divided by 2 is 3. So my axis of symmetry is at x equals 3. 1, 2, 3. Okay, and if you notice, these points are halfway between it. Now we're going to solve for the vertex. Remember, our vertex will be on our axis of symmetry. So we know the vertex has an x-coordinate of 3. So what we're going to do is we're going to evaluate this equation at x equals 3 to tell us the y-coordinate when x equals 3. So we take y equals x squared minus 6x plus 5, and we're going to evaluate that at x equals 3. So I'm going to substitute 3 in for x. So y equals 3 squared, which is 9. 6 times 3 is 18. 9 minus 18 is negative 9. And negative 9 minus 5 is negative 4. So when x equals 3, y equals a negative 4. X equals 3, y is a negative 4. And we have a quadratic. Let's do that one more time. So, again, I went ahead and already solved for my y-intercept. My y-intercept is 0, 8. My x-intercepts are, if you need to, pause the video to see my work, 0, negative 4, or no, sorry, negative 4, comma 0, and negative 2, comma 0. Graph those points. Negative 2, negative 4. So again, by looking at my roots, I should know that my axis of symmetry is going to be here. But let's verify it with the math. Axis of symmetry is going to be root 1 plus root 2 divided by 2. Root 1 is negative 4. Root 2 is negative 2. Negative 4 minus 2 is negative 6. And negative 6 divided by 2 is negative 3. So my axis symmetry is x equals negative 3. 1, 2, 3, and here it is. Right, halfway in between the roots, my vertex will be on my axis of symmetry. So I know that the x coordinate of my vertex is negative 3. I substitute that in to solve for the y coordinate of my vertex. Negative 3 squared, so that's negative 3 times negative 3, which is a positive 9. Positive times negative is a negative. 6 times 3 is 18. Negative 9 minus 18, or positive 9 minus 18 is negative 9. And negative 9 plus 8 is negative 1. So the y coordinate of my vertex is negative 1. Negative 3, negative 1. And sure enough, I've graphed my quadratic.